Okay, guys, welcome back to this series of video tutorial for this function block programming. Okay, guys, so now this will be part 3. What I'm going to do is to add another control logic for our simple machine. Okay, now this is an exhaust fan. Okay, numbers. Okay, let's say we will try to develop our control logic program by adding more sequence of or instruction. Okay, now okay, so what we will do, uh, if okay, so we will say if ef1 runs, if ef1 run hours exceeds 500, okay, that will be hours, then raise an alarm. Excuse me. Okay, raise an alarm. Okay, so again, raise an alarm and stop, and automatically stop, excuse me, automatically stop the fun. Okay, so that is an additional let me see. Okay, so this will be our additional instruction, part of our sequence of operation. If ef1 run hours exceeds 500 hours, 500, okay, then raise, okay, so maybe my grammar is not correct, guys. By the way, I'm not an English native speaker, so please bear with me if I have some grammatical error here. What is important here is you learn the programming. Okay, so hopefully, so if ef1 run hours exceeds 500, then raise an alarm and automatically stop the fan. Okay, so that will be the coverage of this part 3. Okay, now let me show you. Okay, wait a minute. Okay, now as per the instruction, if ef1 run hours, so this is our run hours, exceeds 500, then raise an alarm and automatically stop the fan. Okay, now here we're going to introduce new block. Okay, so if you will right click, then you can see here operator. Okay, so what are the operator here? So we will select. So we have several operator here. Okay. Now, as per the instruction, if it exceeds the runtime accumulation exceeds 500, so what I'm going to do here is I need a greater. Okay. Let's use greater than. Okay. So this is the operator that I'm going to select. Okay. So this is my operator. Okay. Now operator block. Since I am being asked for the run hours, so I'll be needing the output of this. Okay, so I will connect this here. Then I'm going to compare it with a set point because I can consider this 500 is the set point or run hour set point. Okay, so I need some values which has 500 initial value here. Okay. So let me use another block here. Now I will use here parameter value real. Okay, PVR. Now real is a data type wherein the value is a whole number or a whole number with fraction parts. Okay, or floating point part, or it could be considered as floating point number. Okay, so meaning whole number. It could be positive or negative, but this time we need only the positive whole number with fraction parts. That is real. Okay. Now, so I need this. Okay. Then let me identify this first. Again, I can make it public. So I can use it during the binding part of the graphics for this specific equipment. So how I'm going to identify it, I will say, okay, EF1 run hours SP. Guys, I will say run hours SP. So I can say the description is run hours set point. Okay. Now, since I'm being asked if it exceeds 500, so I will say my value here will be 500. Okay. Okay. Now, guys, actually, the purpose of run hours is for the maintenance of the equipment. Okay. Now, if you will be part of the maintenance, then you will be performing some preventive maintenance schedule for this fan. Let's say the fan is being driven by a motor, or let's say it is belt driven, then the belt, from time to time, you have to check for the correct tightness of the belt because uh, it can get worn out. Okay, so maybe after a month this belt will be what you call this loose. Okay, so you need to do some preventive maintenance. Then maybe the bearing of the motor needs to be lubricated, or also the fan. Okay, so that those are the maintenance that the we need to do for this fan. Okay, so since I'm using an operator here greater than, so I'm checking the output of this block if it is greater than the set point. Okay, so it's like we are having a comparison here. Okay, so let me connect it there. Okay, then the output of this operator will be binary, meaning it will be true or false, 1 or 0, high or low. Okay, so if it is true, then as per our sequence of operation, I need to stop this automatically. Okay, so I need to remove this first because I'm going to insert this logic. Okay, then okay, I need to stop it automatically. So what I'm going to do here is create another. Okay, I need a block here. Okay, then I will use a NOT gate. Okay, so okay, then I need another AND gate here. Okay, guys, by the way, we are just using combination of logic gates. Now, maybe you will say, oh, maybe I will be using so many logic gates. Guys, we are just started this series of tutorial. There are some other ways of doing this. Instead of AND gates, we can use expression block. Okay, later we will cover that one. Don't worry. Don't get so much excited. Just follow me and I will walk you through with this tutorial. By the way, guys, I tried to learn this on my own. I did not receive any formal training with this. Okay, so I'm trying to learn it. Then I'm trying to share it with you. Maybe someone out there is more experienced than me. Then we are happy to hear from you where you can give us some tips how we can improve our logic. Okay. So as I said, I'm not expert. I'm just trying to help beginners. Okay. Now I will connect the output of this NOT gate to the inputs of my last AND gate here. Then I will bring it here. Now I already satisfied the first. Okay, this EF1 run hours exceeds 500. Then raise an alarm and automatically stop the fan. So I already consider this run hours. Then raise an alarm. Okay, so if this is true, the output is true here, then I will raise an alarm. Okay. Now I need another simple block, this time alarm. Okay. Okay. So now, okay. Okay, so this one, I will make this one EF1 main, that is short for maintenance. Okay, alarm. Okay, unit then. Okay, so I can say here EF1 maintenance alarm. So as I said, the purpose of the run hours, basically, if you are in the maintenance department, that is to notify the maintenance people that we need to do a preventive maintenance for the said equipment, especially if it is a mechanical equipment. Okay, for the wear and tear, we need to protect our equipment for the wear and tear. Okay, then delay on immediately. Okay, I can put some delay. I can say 5 seconds before it will uh, do the alarm. Okay, delay off. Okay, no more delay. Okay, alarm, OP alarm. OP alarm, I think this is for the operator. Okay, because before there is some handheld operator device wherein you can see also the alarm there. Okay, OP alarm text, I will say this one is EF1 maintenance alarm. Okay, if EF1 maintenance alarm, if it is reset, then back to normal. Back to normal. Okay. Okay, then I will say okay. Okay, then EF1 maintenance alarm. Now, if you are the BMS engineer, you can also raise an alarm here. Okay, so I will create another alarm block here. Alarm. Okay. Now this one, okay, I will say if there is fire here, I will create a node here. Right click, then create a node. Okay. So this node I will use for announcing that there is fire alarm. Now, because as you know, fire alarm will automatically stop our ventilation fan. Okay. So once again, I need to identify this one, fire alarm. Okay. And okay, then edit, I will say, okay, wait. My OP text here, I will say fire alarm also. Then edit. Then I will say fire alarm. Okay, back to normal. So meaning there's no more fire alarm there. Okay. Now trip. Okay, I already have an alarm for the trip. I already have alarm for the okay. Now, for the hand-off auto, if it is a very, or this is a critical equipment, you want it to operate 24/7 in automatic, then you can create an alarm. If it is not in auto, then you can create an alarm to notify the BMS operator that this equipment should be always 24/7 in automatic. Okay, so maybe if that will be the case, then you can create an alarm. Okay. Now, what is important here is to check our logic if it satisfies this. Actually, we did not change any logic. The previous logic, we just added the number 6 instruction here in our sequence of operation. Okay, so you can say save. Okay, now we did not specify any physical points. So we had just created software points. Okay, I hope you know already. If you are following this tutorial, you already have an idea what is the difference of physical points, which are the inputs here and the output here. Okay, so these things in the process part are software points. Okay. Okay, then let's save this. Save. Okay, so if there is no any error, it will be saved. Then we can go to the simulation part. Okay, now I have a problem here. Fire alarm. Why I have a fire alarm here? Okay, fire alarm. Okay. Now because this is, I think, similar with my uh, identifier here. So you see, when you try to save, these are some logic error where where it cannot be traced or cut during saving, but during option, it can also be during simulation. Okay, so you can redefine the identifier fire alarm. So this is the last identifier that I special. Okay, fire alarm. Okay, so to make it uh, status. Okay, just to make it different from the uh, previous one. Okay, then we will try to simulate now. Okay, so meaning we are not we don't have any more errors, so we can proceed with the simulation. Okay, guys, now to simulate this, we need to execute so that it will cycle. Okay, cycle. I hope you understand what is meant by cycling this one. Okay, so meaning my system is trying to check all the inputs, then after checking all the inputs, it will produce the output. Okay, then it will keep on cycling on the control logic. Okay, now first thing what we need to do, as you can see here, the fan is not yet started. Okay, so our logic did not give the on command here because we are not in automatic. Okay, so first we have to put it in automatic, then there should be no fire and there should be no trip, then our uh, command to start is given already by our logic. Okay, now to test the number 6 instruction here, then we need to first we need to actually guys 500 is very long. Okay, so let me go out of the I'll go to edit because 500 is too much. Okay, now I can just say let's say this one is only, let's say 20 only, so that we will not wait for a very long time. Okay, option simulate. Okay, now it's running. Then before the runtime block will start counting the hours, it needs to receive the EF run status. Okay, so EF run, I will say when I gave the command to start, then my motor control started the fan, then I received a run status from the motor control or from the differential pressure switch. Okay, so I will say I received the run. Okay, EF run. Okay, what happened? Okay, I need to execute it. Okay, now I received the run, then my accumulator is started counting. So watch out guys, because we need to see if this start stop command will be off automatically to satisfy number 6. Okay, 17, 18, 19. Since our operator is greater than, when it reaches 21, then as you can see here, then when it is stopped, of course, our run status will be gone. Okay, so meaning, so in maintenance alarm is 1, meaning it will appear in our system. Okay, so we have an EF1 maintenance alarm there. Okay, now our EF1 start stop command automatically go back to 0 because of this inserted and black. Guys, you have to memorize what is the truth table of an AND gate. I have a 1 here, but I have a 0 here. Of course, my output will be 0 and it will be fed to the digital output block. Okay, then my EF1 run hours accumulation is stop at when it should be stopping in the real application. It will stop at 21. Okay, but because we are just simulating, it take me some time or several seconds to remove the run status. That's why it reached 27. Okay, now I hope you get or you grasp the concept of run hours being used for maintenance and stopping the equipment automatically if the run hours exceeds the set point. Okay, so this step. Now guys, this set point, we can make it adjustable or BMS operator adjustable, meaning the BMS operator can adjust this. Okay, so in our graphics, we will show you how this thing you can change this one. Okay, now the run hour set point, I changed it to 20 so that you will not wait for very long time before we will see this logic. Okay, so guys, now we have here the reset. Now let's say the maintenance alarm was already raised, then the maintenance people did some maintenance, then the maintenance people will notify the BMS operator, and the BMS operator will log in this activity so that during meeting of the maintenance department, they will say, okay, we did this maintenance in this equipment on this date, on this hour. Okay, now if it is okay, then the operator can reset this one. Enter. Okay, then as I said, do not leave it in a on in one. Okay, now the runtime is already reset back to 0. Okay, so let's try to. Okay, now again, as you can see, it will start again my fan automatically. Then I say I receive. Okay, then again, my runtime accumulator will try to count again the run hours of the equipment. Okay, so when it reaches 20 or when it reaches 21, automatically again, it will stop my fan automatically. Then it will raise the maintenance alarm. Okay, as you can see now, automatically it stopped there. Okay, so that is one of the logic that you will implement in your control. Actually, there are so many things that you will try to include in your control. As long as I said, as long as it is being asked from the sequence of operation, then you need to provide it. Okay, some of the engineers, they will say, I have encountered some problem when I was doing the one of the projects in Qatar. Then the solution provider, Siemens, they sent someone in the site as a BMS engineer, which is not very good in programming. So when you tell him, okay, include this, then he will always complain. Then he will call their office. Then they will complain about me. Santos is asking too many things. Okay. Now, guys, actually, in a good engineering practice, even though it is not being asked in the sequence of operation, but if you know good engineering practice, you will include run hours monitoring. Okay, because if the consultant is very good, he will look for these points. Now you will say, to the consultant will, you may complain, it's not being asked from the sequence of operation. Now the consultant will always, by the way, the consultant will always play safe. Okay, the consultant will always play safe. Bear this in mind. Okay, if adding some control here will not give you so much time, then add it here, especially if it will follow good engineering practice. Okay, because the consultant will always play safe when they approve your graphics and when they approve your schematic drawing, or maybe you will try also to, maybe they will ask also the logic. Then they will say, you are the expert, you know what you are doing, provide what is not being asked from the sequence of operation. Okay, so as I said, when it is not very time consuming for you as BMS engineer or doing this program, then you can include it in your logic. Okay, you are not making any difficult logic here. You are just trying to add something so that you will help the maintenance people in the operation of the equipment. Okay, I hope you get what I'm trying to say here. Okay, guys. So again, I think this is enough for this part 3 because I don't want to overwhelm, because I'm referring you are beginners in this thing. If I will keep bombarding you with so many logic, I want you to appreciate it from easy to going to complicated. Okay. because I later on I can tell you something which we can break down the logic if it will become very big. Okay, so once again, thank you very much for watching. And if you are new to this channel, help me promote it. Then you can always show your appreciation by going to my page or my channel. Then you can also see some ways there for appreciating what I'm doing. Okay, guys, you can see there the super thanks, and also if you want to help me, you can join the channel for 1 month so that you can help me in doing what I'm doing here. Okay, so again, thank you. Before I will end, thank you very much, and God bless us all. Let's all be safe, and bye for now.